Be right. You get 2 minutes. I didn't get your slides uploaded. I'm sorry. I'm going to try to read a little bit.
I was just going to mention that.
Yeah.
I think that I'm going to accept the errata.
Oh, okay.
If you can upload the slides, if you got.
Did you send them to her too?
Yes.
You're not first, are you?
Oh, I can probably
I
find it.
don't think I'm on the agenda.
For your slides?
No, there's something else.
Tim's slides on the right.
Oh,
No.
no, we don't have time for that.
I don't think so. Second, yeah.
All right, I need to take a deep breath.
There they are.
Yeah.
That's what I tell her. Yep. I got them.
All right. I did not. That's for everything. We're going to be behind the start.
Oh, that's okay. I can move fast. You don't even know. Oh, is it time?
No, yeah. Well, it says 10. Give people 2 more minutes.
Oh, we got a minute. Okay. Oh, wow. Good afternoon, everybody. Looks like everything's sort of settling out. So welcome to the second hour or the third hour of Dnsop. Tim, Suzanne, you know us. If you don't, et cetera, et cetera, et cetera. And Paul, there's Paul. Say hi, Paul. And there's another Paul. Paul's going to take minutes. Dan, could you jabberscribe a little bit? We'll just make sure that we'll move through this kind of quickly. You know this note well. Whoa, the blue sheets. Oh, man. Yeah. So I'm on. Okay. It's warming up. I'm basically onto this slide that talks about blue
And the blue sheets have already been released.
Yep, the blue sheets are out there in the wild. So, quickly, where's Mr. Lawrence? Raise your hand, Mr. Lawrence, so I can see you. I can't see Mr. Okay, so there's a gentleman and Mr. Edmonds, is he, okay, sorry, I didn't mean to scare you, but there's a gentleman from Time, Jason, where are you, I talked to, who has an interesting CDN DNS problem that I think the two of you, he would like to pick your brains a little bit. So I talked to him and I said, I think you need to find the smarter people, and those are you two. So I apologize for that. So, so you know the blue sheets. This I hope. So quick agenda bashing. It's time for the bad idea fairy to come. You know. So if you remember Andrew's slide from who knows where. So, wow. This is really kind of bummed me out. So we had a discussion. I know. Talk about that. This end of the day. It's my brain's a little fried. We had a discussion this morning with some ADs and some of the working group chairs about the DNS, the various transport things. And Warren suggested a new working group, basically called DNS over new transport, or don't. so I got to give Warren big props for that. Thank you, Warren.
We figure if that one is chartered, we're done with the acronym game in the IETF forever.
Yeah,
we
exactly.
win because
that way all the drafts can say IETF don't DNS ...
You do realize that if we get a working group from dispatch for DNS over HTTP, it's going to be called DOE.
No. I think it will.
And bonus points for involving both DNS and transport.
Exactly. So rather than HTTP over DNS and stuff like that, here's our agenda. Wes has got a little talk about multi-responses and multi-queue types. We talked about this. And we spent a lot of time trying to remember what meeting that was, if that was Berlin last year or Argentina, and I'm still kind of confused. Peter is going to speak about XPF for Ray. Is that correct? Yep. I have to tell your boss that you get a gold star. Warren's got extended error. There's client ID, DNS capabilities. Robert's got one slide that I made for him. I'm first going to make DNSSEC validator requirements. And actually, the algorithm one, Shuman's at the bottom of this, and for some reason, it's hurting me. So what we're looking for is basically, in these discussions, kind of think of it as lightning talks, right? Are they worth adopting? Do they need work? Are they like, no way, go away kind of thing? And we're not looking for large architectural poundings, you know, at the mic, but just like, yes, like, needs more work, support, you know, whatever, that kind of stuff. Because, you know, and that stuff, you know, we can throw it to the mailing list. But we just want to get that sense of, should we start, you know, here's our pile of stuff that we're thinking about, you know, moving forward, people are very, you know, seem interested in, where are we going with it, right? So that's basically it. I got some slides from Warren about the TLS usage. I'll throw them up right now, and then it'll be on to Mr. Hardiker sort of thing. So thanks. What's that? Where are these? Yep. So Warren, you said one client went a little crazy. Oh, it looks a little. Where is Warren? Oh, Warren's hiding. It's okay. Oh, that's the spike that you were talking. Is that the spike you were talking about? Oh. Yep. Yeah, pretty pictures. We'll upload them. Just sort of showing the TLS or usage, the DNS usage, and the TLS usage. And yep. And we're going to let Warren speak because he is the AD and he asked to.
Look, they're pretty graphs. They're pretty graphs that shows stuff.
Okay.
What I actually wanted to say is we have an open errata on 8078, which I'm not completely sure the conversation ever converged. If people wouldn't mind having another look and commenting. To me, it looks like the errata should be accepted, but a little bit more feedback would be good. That's all.
Okay. Wes. Clicky thing. Clicky thing. I need a click.
I also need a microphone at a reasonable level. All right. So really briefly, I'm going to go over sort of two concepts that we've talked about. We talked about them not at the last IETF, at the one before that, and a decision was never really made about what to do with them. And I am not clicking. No, that's nice. Technology these days. It's ruining all my jokes, darn it. All right, so both this one and, if I could go back to the title page, the Q-type document and the multiple responses document. They're both solving two different problems. So is Ray Bellis in the room?
No. He's,
okay.
It's remote.
And unfortunately, because he helped author these slides and he doesn't know it. All right, so next.
Okay. Well, it's actually painfully breaking us, isn't it?
All right, so back in the good old days, in like the early 1900s, clients would like use anything that you sent at them. And that included anything in the additional section. So they would take it and as a good leap of faith. They said, you know, the internet in the early days was all trustworthy and nobody bad existed. So yay, next. Then along came the dark and dreary Middle Ages, where cash poisoning plagued the land. And the additional section, all the code was rewritten so that the additional section was like just dropped. If it wasn't useful, if it wasn't in zone, even if it was in zone, but not what you were expecting, it was tossed out. Next. Enter DNSSEC. It's a new era and everything can be happy-go-lucky again because we can actually validate that those records are valid. And it's not even just DNSSEC. So some more recent code bases, including, according to Mark, you know, more recent versions of Bind actually will accept some records as long as they're related. So if you asked for MX and it gave you back an A record for the MX, you know, it was all happy-dunky and that's about what you were going to ask for anyway. But that's not the, you know, that doesn't always happen. So these two documents kind of fix that problem. Next. So two things. There's two different problem cases, which is the thing I want you to take away from today. Two problems, not one, or two optimizations. Some is when you have a smart client. The client actually knows ahead of time it needs more information. It might need to look up both an A and a quad A, the quintessential example. It might need to look up If it's going to send you mail, it's not just going to send you mail and ask for the MX record, it's also going to ask for your NS record if it hasn't been there before. So it's probably going to ask for both, right? Multiple queue types, that document is what lets you do a smart client area. So they're saying, I need like 15 queue types. Who knows what they're going to ask for? Next.
Failure here.
Yeah, sorry.
That's all right, it's my fault.
So the other possibility is that the client actually has no clue what to ask for. It's starting a whole chain of stuff. And it's going to ask some question first, and then that's going to follow on, and it's going to come back later and ask more questions. It could be because there's application-specific knowledge, and there's no way in the world the DNS protocol knows it ahead of time. It's not possible. So this is the multiple responses draft, which is that. So when I say our draft, I should have changed that to multiple responses. I originally wrote this from a single point of context. So this is when the server has a better idea than you do of what you might need. So for example, if you go to www.example.com, there's a decent chance you're going to come back and look up images.com and javascript.com and who knows what, especially if you're doing lots of round robin mixing with names. If you ask for the example MX, you might actually come back and ask for the TLSA record later on as well if you're doing Dane, for example, and that's not something that a current name server will ever include in the additional section at this point. So next. So if we compare these two different drafts, they're actually solving completely different use cases. So, in both cases, the client indicates desire. There's a bit in the EDNS0 field. In both drafts, there's a way for the client to say, I want this. You don't just get it for free automatically. In the multiple responses case, the client doesn't request specifics. The client actually just says, I'm clueless, please help me out and give me additional information if you can. And in the queue types draft, the client actually says, I want as much information for this name as you can, or I want these queue types. For the server selects the specific in the multiple responses case, again, that's the opposite, where the server is saying, you asked for this extra stuff, I'm going to give you a bunch of stuff, all within zone. Both of them support multiple queue types. They can both return multiple queue types for an answer. In additional multiple responses, because it's a little bit more on the intelligence side from the server, can also give you different names back that you didn't even ask for. That's not possible with queue types because that's out of scope of that work. They both use EDNS0 to signal support. Next. So, that ruins the joke too. Stop.
I'm sorry.
That's okay. Go on to the next one. And then make the cursor go away.
We believe in really basic technology around here.
Wow. This is awesome.
End of the week, it's our.
So the important thing to note is that the happy eyeballs that you see down at the bottom, these are both optimizations, right? These are both happy eyeball type problems. Does the world work without them? Yes. They are optimization mostly to do happy eyeballs type stuff on both proposals. Next. Last one. All right, so that's an overview of what they both are. Note that I didn't go into the gory details, right? This is about the concept of solving the problem. And how many people have read the multiple responses draft? Excellent. How many people have read the multiple queue type draft? Excellent. All right, so there's a lot of basis for understanding for these. Now the question is, what do we want to do with them as the working group? And I will turn that to you guys.
I want to do a quick comment on whether or not either one should be no, yes, no, yes. I'm letting you.
Anybody really love this or really hate it?
Thank you. That's the best.
Back to the pink box.
Okay, Paul.
So
5 seconds, go.
Paul Hoffman, I like both, and I currently think both can actually go forwards. I think that'll confuse implementers and things like that, but I think that they're actually both stand on their own.
Okay. Thank you.
Shane Kerr. I love the multi-queue types, and I have no problem at all with the multi-responses.
Yeah, I hate both. Two things. I mean, have we ever seen that there was really stuff on clients done that kind of do new stuff, like how many DOPC? One of the things we see a lot of these ideas is we have no data, and there's a lot of caching in browsers, there are a lot of caching in resolvers. I mean, is this really a problem? Because I don't think so.
Well, so that's one of what the happy eyeballs existed on the screen, right? This is an optimization, not in the same way that all of the entire happy eyeballs RFC is not a problem, right? It was just to make clients happier.
Have we any chance to really have that, because you proposed it as a client stop resolver to resolver thing. My understanding is that the drafts are actually also covering the other side. And I think on both sides, there's no real kind of need for that because caching does all of it.
Caching works if it's a popular site,
Okay.
yes.
Thank you, Andre. David Lawrence, I wanted to say, actually, I love my name is on multi-responses, and my name is not on multi-queue types, but at the hackathon, I started an implementation for ISC's Bind because I really believe in it that much. It should go out.
Andre Suri. I'm actually indifferent, but I think your slide is missing the smart attacker. And so unless you have a really good defense for bloating the responses, then I don't think it's such a good idea to bloat the answers again, because we're trying to minimize them in past few years.
I couldn't hear all that. I think you were saying
Yeah.
that you didn't fully understand the difference between the two. Is that?
No, I was saying that you're missing a slide with smart attacker.
Yeah, so no, we don't describe why DNSSEC is sort of helpful or nice, or yeah, so we also don't have a slide on the children.
No, I mean
So-
for DDoS.
So
For
reflection
reflection
attack,
attacks.
right. So we have plenty of those already in the system, you're right. And at one point, we even put into the multiple responses one that TCP was required, and then we took that out based on knowledge. But so that is a detail of which we can
Yeah,
solve
let's-
in the working group once it's adopted, once the problem is in scope.
Yeah, let's move the substantive discussion to the.
Two comments. If we want to do any optimizations in this space, what do we want to do, is the question. And second, if we're going to open it up, I'm sure there will be other ideas coming along. So I think it's premature to make any adoption choices at this point.
Well, so both of these have been around for quite a while, so I'm surprised there hasn't been other ideas that they have triggered, but
Oh, he's got
I'll
one.
leave that to the chairs.
Yeah.
I have an experiment going on that will result in a draft in the next couple of weeks.
My name is Andrew Sullivan, and I agreed with just about everything you were saying until you said this is merely an optimization. These are optimizations, that part I agree with, but actually they are optimizations that change a bunch of the architectural assumptions about the DNS. Now, maybe we should do that, but I think that analysis has been part of the thing that has been missing. And maybe we need to have a focused discussion about that, because both of these things, right, they change like what you can expect from caches and all the rest of it. I know that they try to deal with some of those things, but it really is a fundamental change to the assumptions about the system. And I don't think that analysis has been written down anywhere. So I think that's actually the first step.
Paul Wouters. I also like both, and we already have a use case for the unbound IPsec module that currently sends 2 queries in parallel, and would be awesome if it could be 1 query. I would also, maybe these two drafts can also help sort of simplify or more standardize the alias or A-name proposals that have been around, so that we have less special processing and that they can use these generic mechanisms.
No comment.
Kazunori Fujiwara from JPNS. There are many other ideas, and for example, draft YAO DNS accompanying question is well written, I think, and there are many another ideas. So I would like to compare all of them.
These are the 2 active documents, and I strongly encourage anybody that wants to write a solution for this space to do so soon.
So it's Dan York proxying 2 comments from the Jabber room. First, Ray Bellis was on objecting to Oliver's comment, saying we had this discussion in Berlin, and he also said, please ask Andrew to send email to the list explaining his comment. And then the second one is from, I'm going to mess this up, but Mukund Sivaraman from ISC. I'm sorry if I slaughtered your name, but he said that he prefers smart clients to smart servers. eDNS client subnet only works on stuff in the answer section. Smart servers can have a performance impact, additional internal data structure queries having a big impact on performance, and it's better if the client requests what it wants and the server provides that than guessing what the client may need that the client may end up throwing away.
Okay. I'm closing the mic line, just in case anybody else was having an urge to get up. Closed. No, I closed the mic line, sorry.
This was supposed to be a 5-minute talk.
Yes.
I think both ideas are worth exploring further, but I would also hope we can try and get some data or objective data to measure which of these optimizations is likely to be the better if they're orthogonal to each other. But before we do it, I think before we actually get these to the final stage in the working group, we really should have something that's based on objective data that will give us an indication as to whether the gain from doing this is actually worth the effort. And I seem to remember back in Berlin last year when Warren was doing something similar to multiple responses. It might still be the same thing we've got now, is that there was a promise then we would actually get some data at that particular stage, and I don't think we've got that yet.
Matt Poundset. I like the ideas behind both of these drafts, and I'm sort of amazed that this didn't occur to me before. Maybe other people have thought about it. I didn't think about it until I saw both the feature sets side by side, but I'm kind of curious now if there isn't a way to do both of these things in a single change rather than two different drafts. Literally off the top of my head.
Yeah, no, I mean, I think that was one of the things that was confusing in Berlin or wherever the previous discussion was. But the reality is that they're two very different cases. One, it's who has the knowledge. And in one case, it's the client. In one case, it's the server. So they'd be kind of hard to combine.
Okay.
Note that I didn't answer any technical questions because we're going to table that and the chairs are going to do whatever they're going to do now. So.
Thank you. And next is, I guess, Peter.
Yeah. Do you have the clicky thing, Wes? The clicky? Oh, I think I got the clicky thing working. So, okay, I fixed it. Sorry. Yeah, I know.
Hello. I'm Peter van Dijk of PowerDNS. This is Ray Bellis XPF draft, for which Remy and I have become co-authors. If you read this draft before, be aware that it has changed substantially since the previous version. So who has read this version? 5 hands, very good. So what this draft does, suppose you have some middle box in front of your DNS server. The DNS server loses client information and this draft fixes this. When Ray named the draft, he mistakenly thought that the similar HTTP header was called xproxied for. It's called xforwarded for. We may need to fix this if we go to publication, so it makes more sense. So to provide some context, long ago, but not long ago, DNS looked like this. You had some machines at home, you had a router, the router forwarded your query either through NATs or as a simple forwarder to a resolver. Resolver spoke to an authoritative, you get an answer back. Pretty soon CDNs came up and this wasn't enough, so we added EDNet client subnet, which allows the authoritative to see at least part of the client IP address. Then people started doing even more complex things, putting load balancers in front of their resolvers, or today, for example, a DNS over TLS unwrapper. This means the resolver no longer has the client IP address, it only has the IP of the load balancer or the TLS unwrapper, which might even be on localhost. So this is where XPF comes in. The load balancer adds a meta record to the query and forwards it to the resolver, which can then add EDNet client subnet information as before. Now suppose the authoritative also has a load balancer. Suppose a query comes in without EDNet client subnet, then the authoritative would still want to know the IP of the resolver asking the question. So again, XPF comes in here to clarify these are the boundaries of these extra messages or extra options. Each option is generated on the leftmost machine in a box, and it is removed on the rightmost machine in a box. So XPF never leaves a network. It might not even leave a machine, while EDNet client subnet will most definitely leave your autonomous system and go from the access provider to a CDN. And to clarify, David Lawrence is going to present client ID later. This is the box for client ID. It is added on the home CPE and travels no farther than the resolver. This is what Meta RR looks like. The previous draft version made it an EDNS option, but we realized that this would make TSIG very hard. So now that it is a separate Meta RR in the additional section, it is very easy to ignore while generating your TSIG message for verification. The IP version is a 4 or a 6, like in an IP header, so it's 4 bits. The protocol is the protocol number from the IANA protocol registry, so TCP or UDP. I did just realize that QUIC is not in there yet, so I hope it will be one day. Then you have the source address, which is an obvious use case for this, but also the destination address and the source and destination ports. This allows the authoritative or resolver that is behind the proxy to still apply views or ACLs, etc. The source port is in there, so you can distinguish different clients in CGNet situations. The destination port is in there, so you can distinguish plain DNS from DNS over TLS, for example. Next steps, I'd like to ask for adoption. And we need to get some code running. Today, a DNS dist does this same thing, but using EDNS client subnet, which confuses matters if EDNS client subnet is also actually in use for its normal purposes. So XPF is specifically designed to be able to coexist with it. Okay? Any
Love
questions?
it, hate it, both.
A little contention problem. Okay. This is Andre again. Why not EDN 0 option? I haven't found that in draft. Why?
The previous version was an EDNS 0 option, but if there is a T6 signature over the query and you are putting another option in the option record, then validating the signature becomes more complex. It's more pointer magic or whatever you like to call it. This is simpler. In general, you put it at the end. In general, the authoritative or resolver will find it at the end and just remove it and then do TSIG processing. It's not impossible as an option, but this seems
Okay,
simpler.
I understand, but I still don't like it.
Can I start by correcting you on one thing? We didn't add client subnet. EDS client subnet is not an IETF standard. It was documented as informational. And it's an example of, I think, kind of protocol development that we should be doing differently now. So I see the use case for this, obviously, but I've said this before, that I think this violates a couple of principles. And one is it makes pervasive monitoring easier. We're supposed to be mitigating that in protocol design. And the other is that this is directly injecting metadata into these queries. So my main request about this is that the document is framed differently. It starts from saying, here's a use case, here's a new option. Oh, and by the way, there are some privacy concerns, and you shouldn't use this in places you're not supposed to.
Yeah, there are some words in that, but yeah, I don't think we have an actual privacy consideration section yet, and we definitely should.
There is one, but it's very, very small.
Okay.
It's throwaway. It's slightly inaccurate because it references the wrong RFC.
Oh.
What I would like to see is an approach more similar to what's in the client ID draft, which is it starts out by saying, we are going to do something that violates user privacy.
Right, yeah,
Here are
I
the
like that text, yeah.
mitigations. Here are the things we can do. So one is about the tone of the draft and considerations. The other thing I'd like to see in terms of the protocol is that this explores other ways to do this that mitigate the monitoring within the protocol. So for example, this is supposed to be between trusted proxies and
Yes.
servers. So you have a relationship with that proxy. So it would be nice to explore how to do this by, for example, encrypting this data with pre-shared keys, as opposed to just assuming it's going to go clear text. So I think
Right.
that should be part of the design considerations, and we should aim for a design which mitigates the monitoring, and only if we don't think we can do that with protocol design, we will fall back to doing
That sounds like you guys need to talk about text.
Yeah.
Right?
sorry, but yeah.
That sounds like this turns into a discussion of adding text, shorthand, send text.
Yes, yes, but I would like to see both those considerations acknowledged before the group considers adopting it.
Okay, thank you. And I'm closing the mic line.
This
Warren, are
is
you in line?
DKG. Sarah Dickinson said everything I wanted to say. Thank you, Sarah. I concur.
Okay.
Yeah, Warren Kumari, one of the authors on the EDNS client subnet document. There's some text in there which I couldn't find quickly scrolling on my phone, which largely said, if we had been designing this protocol today, we probably wouldn't have done it because, you know, we've learned more about privacy and stuff like that. So.
Yeah.
Okay. Interesting. Yeah, that's
Yes.
interesting. Okay.
No, thank you. I think that's good input. Next is extended error.
Okay.
Warren, I think it's you.
Oh, no, it's Mr. Lawrence.
David Lawrence for the remote. Speaking on extended errors. And this is a brand shiny new draft, right?
Was it? We republished on the 3rd.
Yeah, it was from December 2014 and then it was.
Oh, okay.
It is not yet a working group document. It is, of course, published just before the deadline, so I'm sure you're all well informed and highly up to date on it. So basically, hold, this thing is close. I believe, so I just got signed on recently. The original, the 4 authors, Warren and Wes and Roy and Evan, had proposed a 16-bit error code that could be used in an EDNS 0 option to provide additional information about the source of an error. I think the original motivation was driven by this problem where you could have DNSSEC fail and you don't know why it failed. And so the very first 2 proposed codes were both directly related to DNSSEC, where you could either have that the actual validation failed, or perhaps it was indeterminate because you didn't have a trust anchor that told you how it should have established a chain of trust. Then also there was the lame answer, which is because currently we overload in many instances the refused R code to either indicate a policy refusal by the server or perhaps that the zone is not actually hosted on the server. This was the response. You may remember in the olden days, we actually used to return a referral to the root, and that was determined to be too much of an easy amplification in message size, and so servers started returning refused, but that overloaded the other existing meanings of what refused was supposed to be. There's also a prohibited response specified in here that for some reason, this is the other meaning that for refused. And then there's a question that might perhaps be a bad idea, that a too busy error code might be something that would be useful to signal, say, if you were under a very heavy load from a DOS or something. And so this would create another IANA registry for code points, but at the moment it's just these 5 that are presented. We have a couple of feelers out to people to find out what other codes would be useful straight out of the gate, and that invitation extended to all of you. If you have an idea of something that would be really useful in this, please go ahead and send to the list. There was also a question about maybe should it just be a generic. One of the things that this signals, that the existing DNS protocol does not signal, is whether you should retire your query or not. For example, under a validation failure, contacting a different server is probably not helpful. Under other error code conditions, it might in fact, like perhaps you serve fail, but you have reason to believe because you didn't have a data file you expected to have, but you know, your secondary might have that information. And so you could serve fail and then set the bit that says, you know what, this is probably worth retrying this query. But at the moment, there's no particular way, like all of the retry bits are attached to one of those specific error codes that were on the previous slide. There's no way to just kind of generically say, you know what, I don't have an answer for you, but retry. And there were additional questions about whether to have, you know, explanatory text that would explain the error code that you might want to then, you know, poke upward through the UI somehow, exposed through logging. And there was also a question about whether this is currently called extended error, and right now it's only used if your R code is an error R code. Perhaps it should be extended to be able to be used in any situation. And there's an additional question that right now the way EDNS works is you're only supposed to ever include an EDNS option in a reply if it was received in the query. However, by the original specs, it say you're supposed to understand, additional records. And if you don't understand a particular record in the additional section, you just ignore it. There's also a belief that you could maybe push an EDNS option back in a reply, even if you didn't get it in the original query. Whether that should be pursued as a separate, question and not necessarily in this doc is something else. But overall, we are interested in having it picked up as a working group document and move forward with this mechanism for providing extended information about errors. And we're doing questions, so.
Follows. So my biggest concern here is that.
Actually, before we start with comments, again, because this is an older draft that's just recently been revived, we do want to hear real quick takes on it, but also I think for everybody who's in the mic line, we're going to assume that you're going to review, you're committing to reviewing it, because these questions are the right ones and they need to be answered. So what we're really looking for at this stage is review, and I'm calling on our secretary to take down all the names.
As they speak.
I will also emphasize, though, that I believe, even though it's an old document, it was never adopted as a working group item originally. So.
Right, and this is what I'm saying, is that people have either not seen it before or not seen it recently. So the first step, I think, is to get
Posted a week ago.
Okay.
So go ahead, please.
Follows. So my biggest concern is that we're using signaling bits to convey certain error codes while they're not protected by anything security-wise.
Very reasonable point.
Paul from Cloudflare. David, this is not new. People have wanted something like this forever and ever. I had a proposal from last century that I just put in the Jabber room. Yeah, this is great. We should talk about how to do it. And sometimes people want more visibility into it when they are the vendor versus what the public gets.
Yep. Right.
Jim Reed, what Oliver said, I think it's a great idea and it's something that's long overdue. Got one or two concerns and just a couple of things we can think about when we actually get down to work in this document. First of is maybe we want to have some kind of lightweight code point allocation policy like we do with our R types, maybe some expert scrutiny if we need to do that. We should also be very, very careful about error codes that were returned in this proposed format that cause changes of behavior in the recursive servers. Because if you've got things like backtracking, or if you get a validation failure, let's go and try some other server or something like that, that could be a bad thing. But that's implementation detail. I think it's a great idea, long overdue.
Okay, and so one quick thing I want to address, and one thing you said there is as far as a lightweight allocation policy, and I'll end up mentioning this in my next talk as well, that Suzanne, Warren, and I are all working with Diana to try to clarify how we have a couple of registries in the DNS already, and I won't go into too much detail on this, but that where policy for code point allocation is through expert review, and we're working on clarifying how it works for those existing registries, and I think there's text in the document already proposing that this be expert review, but that will be tightened up to explain what that review might look like. Okay.
Okay, Petr Špaček, CZNIC. In short, I support this, will review, but beware, it needs a lot of work first on the protocol and then on the client side, which is always the problem, because if nobody's reading it, why the hell we are spending time on it? Yeah. Beware.
And Chalak and S1, I definitely support this draft. I support adding some extra information about a failure. I don't like having error code in header, EDNS option, like extended error code and some other code point. So I'm just asking if there is a space for maybe vendor-specific error, like a textual information that would be readable to the client, even without reading any code point and then matching it against some registry.
Yeah, I agree that with 16 bits of error space, we should be able to block off a range of vendor-specific codes.
Raj, we were like the idea will support a review. I think it could also be useful for other result codes in error. And I mean, I don't think we should do it for non-EDS requests. And I mean, the other thing that Paul mentioned is right. We need to look at security-wise. I mean, this unencrypted data, how to deal with that.
Right. I would also like to say, Ralph, thank you for actually supporting something I'm associated with.
Get out of my box. So send any other error codes you can think of to the list so that we can add them to the draft. And
yes.
Come say it, Warren. Come say it. You want to, you're dying to.
So when this was written, most of the point was, specifically debugging type information, additional sort of advisory information. So if you get back serve fail, and this leads you down the wrong path because somebody's fiddled with the answer, I don't think it's a huge security thing. You're just going to be confused about where, but I don't think it should actually break stuff. But I haven't thought about it deeply, right? Made up on the fly.
Dan York is JabberScribe. The people remote are saying that the audio levels are low, so speak up when you come to the mic.
Thank you, Dan.
Thanks, Dan.
Anyway, so our illustrious chairs, I think specifically Tim, has suggested that this is the bad idea fairy session. And so this is the bad idea fairy draft with the unfortunate aspect that this is already implemented and out on the network, not by us actually. And so I don't even remember how I organized this slide. I suppose I should look at it. But the main thought that I want to communicate here is my primary concern about advancing this draft is the fact that it's obviously PII, where obviously, it goes beyond client subnet. Here's the full identifier of a person making a DNS query and a request. And I had my own misgivings about, well, can this be done? In part because it's already being done by several vendors. And some of it going across the wide area network. And so my approach to this was much like my approach to client subnet, in that documenting existing practice and perhaps improving on it was probably the better approach to take than just let it continue to lurk in the shadows. But I will right up front admit my own discomfort with the privacy aspects of this. The goal of it is really based around providers, internet service providers primarily, actually being able to enable filtering on DNS requests. And so it is meant to be used between a client network and their full service resolver and not sent out to authorities. The document attempts to address this, perhaps not to sufficient detail, but it does make it at least an initial attempt at doing it. As mentioned here, it is already used on the network, and so the big question is, do we document existing practice, try to improve on it, or just say, well, no, this is a terrible idea and we're going to pretend it doesn't exist? Personally, I don't think that's a really good option. I did incorporate feedback. I sent this out after having sent it to both to Dnsop and dpriv to say, hey, look, there's this PII draft that's out on the network, and not getting any feedback. I sent it explicitly to both Ted, our privacy maven, and to Sarah Dickinson, who did provide some useful feedback on it. And I do want to explicitly say that neither one of them were supporting the draft. They just provided feedback about how it might be less terrible. I also asked for an eDNS code point under the expert review process, and it was denied on the grounds that it was too complicated because it, quote, created a registry of sub-options. And reportedly, it would have been granted if it had just asked for multiple distinct options. Now, I want to say, without regard, this is not, the expert review process needs improvement. And this is not a complaint about our expert reviewer who didn't have sufficient guidance about, what should be considered in granting an eDNS zero option code. It had a lot to do with the UI of how you even initiate the process, and then what you should expect out of the process with regard to any criteria that might grant it or not. And so even though I disagree with our expert reviewer on the grounds for it being denied, at the moment that's what it is, and I'm okay with that. But as I mentioned in the previous talk, Suzanne, Warren, and I and Tim are all working with Michelle from the IANA to improve this process, and we've already seen some of those improvements. Like now, if you go to the IANA registry, it will point you at least to the documents that say, oh, this is how the expert review process was established. To whatever degree it might not really have any sufficient documentation to establish your expectations, at least you know how to begin the process. And so, I didn't mention my co-author's name, unfortunately, at the beginning. Robert Lick, the charter, started this process with us because he had the option to use one of the existing code points, but he felt uncomfortable with it not being part of the visible standards process and wanted, even though we have some software that will go ahead and talk one of the existing options, we wanted really to focus on how can we do this in a right and honorable way, if it can be done in a right and honorable way. And so to that end, the ultimate goal here is to get it adopted as a working group draft, and everything that Sarah said about XBF applies here as well. You know, those points are very well taken by me. Nonetheless, my opinion is that I'd like to see it move forward in a respectable way. I will mention, though, the flip side of it is, if the working group doesn't adopt it, we don't make it a public standard, I know we're going to implement it anyway. For the purposes that Charter wants, we're going to implement it using one of the existing option codes because that code is already there. And we actually have within our organization something I can't say too much about, but essentially they need an opaque token that is supposed to be sent across the wide area network. And if you've read the draft, you see that, you know, we demand that this be, you know, protected through like a TLS channel or some other kind of secure resolution process, which would not expose the data. And until we move forward with this draft, what they were planning on doing was basically co-opting OpenDNS's code and using that. And if this doesn't go anywhere, they're going to co-opt OpenDNS's code and use them. So the reality, once again, facing the DNS, not just Dnsop, but the IETF in general, is how do you balance the competing interests of wanting to do the right thing on the network with the understanding that if you don't do something, it's going to happen anyway.
I have the best seat in the house. It's right next to the microphone. Sorry, Paul Wouters. So people came to us, to the working group, and said, we need this, you know, EDNS subnet, you know, we've deployed this already, and, you know, we're just documenting running code. And we said, we really don't like that, but fine. And now you're coming back and saying, we have running code. It's actually worth just saying, we will write running code no matter what you do, so please adopt this. And I think it's time to actually put a foot down and say, well, not further. Like, we should, because a year further, you're back again with more privacy disabling features. Like we should stop doing this.
Sarah Dickinson. So I want to applaud all the efforts that are going on to document what is being done regardless of what we do, because that's really important, because people, a lot of technical people are completely unaware that this kind of thing is happening on the wire. So as a minimum, I would like to see us at least do an informational draft to document what is being done. Oh, sorry. So as a minimum, I would like to see us document informationally what is being done, what is really, really happening out on the wire, because that in and of itself is compromising users' privacy. Whether or not we, you know, do any further work, I think that I'd like to see that sort of as part of our role. I also like the way the draft is written currently, because it does acknowledge the problems around this. It tries to talk about some of the principles around exposing this kind of information, making it opt-in, doing it over TLS. I'd also like to think that we as a working group could constructively try and help solve these problems if we can in a privacy-preserving way. If we don't think we can do that, that's when we come to the debate that places like TLS and Crick are having all the fun of, you know, these massive fun fights over this sort of thing. But I think we need to be very careful about where we draw that line, because I think we want to be doing everything we can to do both of the things, which is preserve user privacy and provide usefulness on the network. So I think we should be at least exploring this.
Okay. I'm closing the mic line, and again, suggesting that everybody in the mic line is now committed to reviewing the document.
Hello, Peter van Dijk, Power DNS. At least 4 people in this room, probably more, are doing this today on squatted points. Please adopt. Thank you.
Ralph Weber, nominum, I'm going to surprise you. I'm supporting a second draft. So yeah, I mean, this is good work, needs to be done.
Stefan Bartsmeyer. I don't commit for reviewing because I think it would be a bad idea to adopt it. Basically, it raises too many privacy issues, and I especially want to say that Section 2 today is really, really weak, suggesting that it has to be opt-in by the administrator of the network. It's no good. It's privacy should be under control of the user, not the administrator. On giving as an example, reading terms of use and clicking yes, I accept is certainly not a reasonable way to accept something. People click on everything every day. It means absolutely nothing. So it's a really, really bad example, and it does not feel good from a privacy point of view.
So I actually really agree with you on that. One of the things I can mention, as I was trying to make it, because the original protocol as it was sent to me saying, hey, can we work on this, didn't have any of this. And the question I was trying to address was essentially the situation of, a homeowner trying to establish, and I might be all wrong about this, I'll say that right up front too, but a homeowner that, parents that are trying to establish parental filtering for their children, I could see where even they would then go through and enable it on all their children's devices because that's what they're trying to do. And they would go through a very conscious process of doing that. Like in an ideal world, that's what I'd love to see happen. Until their friend with the iPad comes over and is now on the network and everything is just fine and is not being filtered the way they expected things to be filtered. And I agree with you very much that I want to see people make conscious choices in life, not just about their privacy, about their diet, about many, many things in life that don't happen because I click right through EULAs too. And so it is a problem, and I don't have any good answers for how to address that problem.
This is Daniel Kahn-Gilmore. So from the ACLU. So I do appreciate the attempt to document privacy violations that are ongoing on the network today. I am disturbed by the eagerness to try to make this more flexible with even more privacy invasive options. The idea that there's a registry of sub options, or that there would have been a registry of sub options. I'm trying to imagine what that is. Social security numbers, credit card information.
So,
so my question is, at what point do we draw the line and say, this information is not actually a reasonable piece of information to continue to retransmit on the DNS? The DNS is not made for this, and we should not be transmitting it.
Right, and so I'll mention the other aspect of that for those of you who haven't read the draft. Essentially, and this was our expert reviewer's concern. And I haven't mentioned him by name because we're still buddies, and I'm really not upset with him for denying it because he had reasonable grounds on, in his mind. But essentially it proposes to use address families. So a MAC adder or IP address, OpenDNS uses both of those, for example. But then also had the flexibility to use, as it turns out, DNS names have an address family assignment. And so use the address family assignment of a DNS name to be able to indicate essentially a domain name within somebody's control. And as I mentioned, we have a security division product that is really meant to protect people talking, a business client that's in their local coffee shop and is connecting to their secure resolver across the network and being able to send this opaque token, which does not actually fit in the in an address family identifier because it includes actual user identifier. But it's a token that is meant to be hidden across the network. It's a security product. But that's where kind of the confusion comes, because if it uses a domain name, essentially it's infinitely extensible, right? And so you could put anything under there defining what your personal domain name uses.
Palvax. So just to and reply to Sarah, unfortunately, outside of the IETF, nobody knows the difference between an informational RFC and a standards track RFC. They just know RFC. So if we document something in an RFC, then that's basically signaling to the world outside of IETF that this is something you should support and implement, and it's a standard. So I really want to push back against that notion. Leaving it as a draft is something I could see doing, but publishing as an RFC is basically, in the eyes of the world, a stamp by the IETF.
So that brings up an interesting point, if I can have 2 more minutes. One more minute really quickly, because
really short on time here.
Suzanne had asked me to bring this up on the terminology document in the last session, and I just didn't. But essentially, there aren't actually many DNS standards, what the IETF considers as standards. There's a lot of proposed standards, but there's nothing that's actually become a standard, and not any of the things that you would expect to be standards. And most of those only happened within the past couple of years, the 5 of them that are. So one of the problems we also have to face, and this became an issue for me recently because I had a situation in the company where we had a reverse delegation that had to be assigned through RIPE, and it didn't have, or we didn't support TCP on the one server that RIPE connected to, and so they pushed back and said, hey, standards require TCP. And the guy that came to me about it, I said, yes, standards require TCP. And he went and looked up the standard and he said, it's a proposed standard, it's not a standard. And I'm like, well, as far as the DNS is concerned, proposed standards are standards. But we should be better about moving things that are proposed standards to being actually standards. Because for that same set of people that think that informational or proposed is a standard, there's another set of people that thinks that informational and proposed are nothing. So somehow we have to really start hardening that. 59 seconds?
That's good.
Okay.
Well done. And yeah, we have time for one more.
No, Robert, I think we got bumped, and I apologize. Shuman, you better be here or else you lose your spot. So.
Basically, you're standing between people and bits and bytes, so use their attention wisely.
Okay, so this is a proposal about algorithm negotiation in the NSSEC. And so Haya Schulman, who I think some of you know, she's done some work with DNS privacy. She's presented at IETF in the past. She did some early work on this mechanism. So she's very much a part of this. And this week, Shane Kerr gave me some useful feedback, so I recruited him also, or perhaps tricked him into joining me in this document. So let me try to motivate the proposal by talking about the use case we have in mind. So a zone operator wants to incrementally deploy a new DNSSEC algorithm. And also they don't want to disenfranchise the population of resolvers that don't yet understand or haven't been upgraded to understand the new algorithm. And we know this is going to become an issue in the future. There are new algorithms being proposed or already appearing, and we know there's other stuff that's going to appear in the pipeline. So what the zone operator can do is deploy both algorithms and then monitor, somehow have a capability to monitor its population of resolvers to figure out when they have been upgraded to support the new algorithm and then withdraw the old one. So some of this can be done today. So the DNS protocol certainly supports signing your zone with multiple algorithms and returning signatures with multiple algorithms in the responses. What it doesn't have is an easy way to monitor when clients are upgraded to support new algorithms. But there are issues anyway. Zone operators often don't want to unnecessarily load the size of their responses with additional signatures because of a variety of operational problems they cause. And these are all well known. The response may end up exceeding the path MTU or perhaps the IPv6 minimum MTU, causing it to be fragmented at the IP layer. And we all know that fragments don't successfully transit the modern internet today because they're often blocked by middle boxes and security devices. The zone operator could, when a response exceeds the path MTU, truncate the message and cause the client to retry with TCP, but that involves an additional round trip, additional latency, and additional processing costs associated with TCP. And perhaps the zone operator hasn't upgraded their infrastructure sufficiently to deal with TCP, DNS over TCP queries on a large scale. So while I was here this week, several people told me, well, you can do this today, you can just deploy the new algorithm, because DNSSEC, of course, fails open, so nothing breaks. So nothing breaks, of course, except security, and maybe security is important to you, right? So obviously you lose the benefit of clients being able to authenticate your DNSSEC data. And furthermore, it may end up being a critical problem if you're using DANE applications, which have a critical dependency on DNSSEC authentication. So they really can't afford to fail open unless the application mode of using DANE is entirely optional or opportunistic. So that dissuades them from deploying or adopting new algorithms. So the proposal here is essentially a new option, of course. That's the way we extend the DNS. That allows the client to specify an ordered list of algorithms they both support and prefer, and the DNS server upon receiving this option, can attempt to select the best or strongest algorithm they support in common with the client, and then selectively deliver DNS signatures only associated with that algorithm. So you can read the draft for more technical details. I know, Susanna, I have way too many slides. These are just for reference, so you can, I'm not going to go through all of them. So we have a couple of proposals, how it can be done and how you can implement algorithm downgrade protection, which will be important if we do this kind of algorithm negotiation. So you can go read those. This would be a relatively simple protocol if DNS were a, point-to-point client server system. We all know it's not, right? There are caches and other intermediaries in the way. So essentially that problem has to be solved, and we've sketched up how to do that in the draft. We have a little bit more work to do to more fully specify the different scenarios and how it works. But essentially, to summarize, the resolver will have to keep track of which cache entries are associated with signatures from a subset of the algorithms supported, and then if they have a downstream validator that requeries them with algorithms that they don't have, but which are supported by the authoritative zone, they have to be prepared to refetch them. So I'm going to just quickly finish before. Do you want to interrupt me with a question? Or let me quickly go through the slide. So there's some diagrams here about how the cache management would work. And the other thing that this protocol provides, of course, is if you know what 6975 is, that was the original cryptographic algorithm signaling, signaling mechanism, right? Which was standardized and published, but as far as I know, no one actually deployed it. So this protocol actually is a superset of that, so it can provide the same functionality. So a couple of things we plan to do in the future. We're going to continue working. This is a brand new draft. We're going to continue working on it a little bit. We might add the direction bit in the EDNS option, which is something that I've seen in several drafts that Ray Bellis has his name associated with it. So this is essentially to detect broken devices that, without understanding the EDNS option, just blindly reflect it back to you. And before I finish, the other thing we can do is we can decide we don't need to solve this problem because we might be able to deal with it in other ways. So I'm just going to put a list of the potential other ways we can deal with this problem. We can try to mass migrate the DNS ecosystem onto alternative transports that don't have to deal with this problem. So TLS, TCP, QUIC, these guys. I think there was a suggestion by someone on the mailing list that the way to solve this problem is just fix the entire internet so that large UDP fragmented packets work successfully. Personally, I don't think that's realistic, but maybe other people do. But even if it were the case that we could solve this problem, fragments do cause other problems. So Haya has actually written a paper, I think it's a 5-year-old paper, called Fragmentation Considered Poisonous, where she demonstrated a bunch of attacks that she mounted on the DNS protocol using fragments. And more recently, and actually long ago in the past, there have been various attempts, even within the IETF, to completely deprecate the use of fragments. And if you look at, I think, Andre, was it you that mentioned BCP 145 recently? So if you look at the UDP usage guidelines that the IETF has published, they say that if you're a UDP protocol, make sure your payload comfortably fits inside the path MTU, otherwise you're going to have problems. And I'm pretty sure if DNS were designed in the modern way, in the modern day, it would have had an application layer framing mechanism so that you could fragment and reassemble large packets at the DNS layer. So maybe that's another solution, but that's a pretty big endeavor too. So, okay, so that's it. So can I quickly ask how many people have read this proposal? Okay, all right. It's a bit more than I expected. Okay, that's great. And so my question is, should we work on this?
No.
All right.
Yep. I saw in one slide the strongest algorithm, which go back is a term. It's so on the
So keep going.
It was before.
No, this
it
is
was
the
in
first
the text at the beginning. You should say the server should use the strongest algorithm. I'm afraid there is no agreement about from some algorithm which is the strongest. So I propose to change it by most preferred or
Right. So you're saying there's no general agreement about how you would rank algorithms in terms of
Yes,
strength? Yeah.
see, for instance, between the DDSA and the CDSA,
Right.
with a curve in the same size.
Yeah.
Can't
So,
say
yeah,
which-
that's a good point. So I agree. So the way to deal with that problem is there's two ways you can do it. You can either have a client-driven preference where the client specifies its ordered list, and it doesn't matter what the server prefers. The server has to pick the most preferred algorithm that it supports from the client's list. That's proposal one that I have documented here. But there's a second proposal where we do the opposite, and maybe this is the way it should really work because I think a lot of people think that the zone operator, not the client, should be able to dictate its algorithm preferences. After all, it is in the zone operator's interest to have the client population authenticate signatures with the strongest algorithm that the zone operator thinks it supports.
But there is nothing like strongest, so only can change in time.
Yeah, so the way, there's another piece needed to make this happen, which is the way that a resolver knows what algorithms a zone supports is pretty easy. You just inspect the signed DNS-PRR set. But it doesn't know the order of algorithms that the server is inclined to use, because there may be some disagreement about how to rank a 3,000-bit RSA key versus an ECDSA P256 for approximately the same strength. So the way we're proposing to do that is at the apex of the zone, at the authoritative server, we introduce a new RR.
You two should talk after this. Okay, that's really, okay, you two should stop, okay.
This is Andre. I like this draft, and I think we should work on this. But I have one question. If we all move to elliptic curve crypto, is this going to be a problem?
Are you asking if we all move to elliptic curve crypto, maybe we can, well, it depends. I mean, if you move to elliptic curve crypto, there are still algorithm choices, right? So you may have ECDSA P256 deployed, and maybe you want to you want to move to add 255.19 because the former algorithm is tainted by association with NIST or something, right? So you still may have other reasons to transition to new algorithms.
Yes, but I'm asking whether the size of the signatures will be still a problem. If it's, maybe it will be small enough to just send them all.
It's possible, yeah. So I mean, we'll have to measure that, but I think in many cases it could be a problem, right? With NSEC 3, you still have to provide 3 signed NSEC 3 records. You could have chains of CDs.
Again, this sounds like something where your answer now is send text.
Okay, all right.
Because we're actually over time now, and I'd still like to hear from people as to love it, hate it, should we continue to work on it? Although the fact that we're having substantive discussions tends to argue that people do want to work on it. But I do want to hear from the rest of the line. Thank you.
Stefan Bartzmeyer. Dnsop has a great capability of producing internet drafts with new EDNS options, so maybe it would be a good idea to consolidate a bit. And it seems to me that this idea could fit in the DNS capabilities draft by Robert Edmonds. At first glance, it seems compatible, so maybe that's something to consider before deciding to adopting this idea and to discuss on the details.
Okay, yeah, that's a good idea. I actually can't remember what's in Robert's draft. Yeah, this is the capabilities draft, right? So I'll have to go back and read it, but thanks. I'll look into that.
DNSSEC already is fairly complicated. This makes it a hell of a lot more complicated. I don't think that will actually help with the adoption of DNSSEC because we still have huge gaps in kind of DNSSEC adoption. So I'd rather work with what we have, which seems to work roughly okay, than to kind of add more complicated stuff that will actually people say, oh no, these guys are still thinking about it, maybe not implemented now.
We couldn't get 3 out of you, Ralph, could we? No. Okay.
Petr Špaček, CZNIC. From my perspective, as a resolver implementer, it's a nightmare because it will blow up the number of queries because, just think about this.
Right, sure. I mean, in the beginning it won't. It'll just be a marginal increase, but certainly the cache management is a little bit more complicated, right? So,
Definitely.
to some extent, we're already have 1 foot squarely in this boat because of the client subnet. We're doing kind of the same things with that, right?
No, I'm not saying discuss it right now. I'm saying just it will have bigger consequences than it seems from the first glance.
Yeah, okay.
Andreas Schulze. I like the idea. It introduces algorithm agility to DNS, which is generally a good thing. And I suggest to talk to the TLS working group, which had similar problems because of downgrade attacks and such stuff.
Sure. Yeah, so this algorithm negotiation mechanism, proposal 2 is roughly like TLS, where the client expresses its list and the server picks the strongest one.
Oliver, you get the last word.
Thank you.
Yeah, I know you've been waiting for this.
I'm not going to repeat what I've said on the mailing list, but I think this is a horrible idea.
Okay.
The main thing is, like Ralph said, this will actually delay the NSSEC deployment because people will think we're not done with the protocol. And to answer your question, when it is safe to deploy an algorithm, we have techniques already, like George has shown us, how to detect how much is validatable by what algorithm. So it becomes an operator's choice of when they want to make that cut. It shouldn't be baked into this protocol, making more round trips, making resolvers slower, making resolvers have more memory. This just smells so bad on so many different levels, and I can't believe you are trying to delay Dane with this.
Well, so sorry, Oliver, what was the last one? I missed the last one.
Because you're causing uncertainty about the NSSEC deployment, that will delay Dane.
That will delay Dane? Yeah, okay, all right. Okay, so I disagree, but I'm not going to rant now. I'll rant on the list later.
And if you're really lucky, well, if there's enough going on, we'll do an interim to work out some of these things. But for now, we are over time. We don't want to impose on, particularly on MeetEcho.
Yeah.
But thanks everybody for your time. Thanks everybody for the good discussion, and we will see you out there in Radio Land, and we will see you in Singapore. Thank you.
Where is that? Yeah, there we go. And for those who missed Robert's talk, that's essentially Robert's talk right there. So. And who has the other blue sheet? If you haven't signed one, is that back?